Welcome back to another one of my derivatives examples videos where I just basically go through 3 examples for you, show you how it's done or how I would do it, and hopefully you learned something. We have 3 examples per video. This is the 12th episode. They have gotten increasingly harder up to this episode. So there's a technique in here that I showed in my 11th episode, and it was basically I'll get another sheet. It was basically we had x to the power of x, and we used a technique where we would make it e to the power of ln of x to solve, because these two equal the same thing. That's bad drawing, but they equal the same thing. Okay, so that's what I'm going to be showing you how to apply that here. Okay, so we'll start with our first example and we'll go through in order. Example 1. So we have y equals the square root of x to the power of x. Bit harder than the one in my previous video. Okay, well, I don't know if you know this, but there's a rule which states y equals a to the power of b all to the power of c equals a, b, c, where if you have if you have something to the power of something and then to the power again, you can multiply those two powers together as such. So that's what I'm going to do here. Because this is exactly the same as x equal, this is the same as x to the power of half to the power of x. I'm going to multiply these two powers together. Therefore, we're going to get x to the power of x over 2. I hope you can read that's a 2. Anyway, so I'm going to use that technique that I explained before, where have e to the power of ln of x. Basically, we raise this to a power, we multiply it to the power. Keep in mind that this still equals this. This e and this ln technically cancel each other out and make the x go back down to the bottom where it belongs. But if you use the e and the ln like this, you can bring this up as a power, as such. And this stays as a power. But this multiplies on. This is just a technique. I'm not going to explain it too much, overcomplicate it. This is just how it is. This here, the x equals e to the power of ln of x. That's just it. Okay? So, how are we going to solve this? Well, we have ourselves a function multiplied by another function. And we have an e involved. So, the derivative is going to be, whenever you have an e, it stays the same. But then you find the derivative of the power. That's what happens with e. You have e to the power of this. When you derive it, you get the same thing, but then you multiply it by the derivative of what's in the power. So that's going to be, we're going to have to call this u and this v, because we're going to need the product rule. We have a function multiplied by another function. We're going to have u dash v plus u v dash. Okay. This bit stays the same. This bit's different. So u dash. If u is ln of x, the derivative is 1 over x. V is x over 2 plus u, which is ln of x, and v dash. The derivative of x over 2 is half. Okay? So, these x's will cancel each other out because an x divided by an x equals 1. So we're left with a half plus ln of x multiplied by a half. Okay, simplify. First thing, This, we agreed that e to the power of ln of x is equal to x, so I'm going to bring it back to what we started with. Keep in mind that this portion here equals this. It still stays the same. We just changed it so we could find the derivative. Anyway, so onto this part. This is all multiplied by a half plus ln of x on 2. Now, because we have a half here and then another half on this side, we can factor it out and we'll get x to the power of x over 2 multiplied by a half 1 plus ln of x. Essentially, if we expanded these brackets, we would get the same as up top by multiplying this in. Anyway, so what I'm going to do now is multiply this and this on top of the fraction. Therefore, we're going to get that. And that there is the derivative of square root of x to the power of x. Okay. Now, this one should be a little easier actually. But example 2, we have y equals tan x to the power of 1 over x. Just like before, what we're going to do, we have still y, but we're going to raise it. So we're going to have e to the power of ln of tan x multiplied by 1 over x. Okay? Now, the derivative. What's the derivative of e to the power of whatever? The derivative is e to the power of whatever multiplied by the derivative of this whatever. So that'll be u dash v plus u v dash. We'll call this half u and this half v. Okay, u dash. If u is tan x, the derivative of tan x is secant squared of x. And v is multiplied by 1 over x plus u, which is tan x, multiplied by derivative of v. The derivative of 1 over x is, I can't fit it there, but it's negative 1 over x squared. Okay, I'm going to revert this back to what we started with because that equals the same thing. So I'm going to have tan x to the power of 1 over x multiplied by secant squared of x over x, because I'm just multiplying onto this fraction, minus, because we have a negative here now, tan x over x squared. Okay, and the final bracket. Now, well, actually I messed up here. I messed up. Okay. This, I made a problem. Hopefully you picked up on it. If you picked up on it, maybe you're learning more than I am from my videos. But the u dash, that's a chain rule up here. So we have the derivative of the first part, the outside, which is 1 over tan x multiplied by the derivative of the inside, which would be secant squared of x multiplied then by the half the 1 over x. Then we would be adding that to u, which is ln tan x. Then we'd be multiplying that by the derivative. This is getting a bit squished. The derivative of 1 over x, which is negative 1 over x squared. Okay, now that we've fixed that up, bring the equals over here, and we're going to revert this back now. So we'll have tan x to the power of 1 over x, bracket, we're going to multiply this, so we're going to multiply the x and the tan x, so we'll get x tan x, over secant squared of x, minus, because we're multiplying by a negative, so minus ln of tan x over x squared. Okay, and that there is our derivative of x tan x to the power of 1 over x. That portion. Okay. Now I know that was a bit messed up, but be patient. So here we have my third example. Y equals ln of x to the power of cosine of x. We're going to raise this to the power again by having e to the power of ln of x multiplied by cos x, and we're going to do the product rule. So we're going to call this side u and this side v. So when we do the derivative, this will still equal a to the power of ln of x multiplied by cos x, but then we're going to find the u dash v plus uv dash. Okay, so that will look like this. I'll just rewrite this out again. Okay, so u dash, the derivative of ln of x is 1 over ln of x multiplied by 1 on x. Then we want to multiply by v. V is cosine of x, plus u, which is ln of x, running out of room again, multiplied by the derivative of cosine, which will be multiplying by negative sine x. Okay. So now I'm going to revert this back to ln of x to the power of cos x, because we agree that this is the same as this. Now for this side, we have x multiplied by ln of x, which is just going to be x ln of x. We have a cos x, which is going to be on top, minus, because we have a negative in here being multiplied through. This is going to be negative sine x ln of x. And that there is the derivative of ln of x to the power of cos x. Thanks for watching. I hope you learnt something, and have a good day.